And geekiness is good. You want a geek to decide, you know, how your nuclear power station is run, and you want a geek to decide, you know, that the operating theater in your hospital always works.
Welcome to Frank Stajano Explains. Today's topic is why you should come to Cambridge to study computer science. Why you should study computer science at university, in the most general sense. Why you should come to Cambridge, even better, to Trinity College, Cambridge. And especially, why you should do all that, even though you don't fit the computer geek stereotype of the white middle-class boy. Since I am one of those, I thought it would be more authentic to hear this why from someone who is not. It's my great pleasure today to introduce our viewers to Professor Simone Teufel, who is my colleague at the Department of Computer Science and Technology in Cambridge, and who is an expert in natural language processing. Simone, would you please introduce yourself to our audience and tell us what you do and what makes you tick?
Hi, my name is Simone Teufel, and I'm a professor in language and information at the Department of Computer Science and Technology at the University of Cambridge. I was hesitating there because it used to be called the Computer Lab. And my specialty is computational linguistics, natural language processing, and artificial intelligence. And I now do teaching, and I love the teaching part of my job. And I also do research in how people perceive language and how they use language to achieve certain things. For example, I'm really interested in argumentation. How do people argue? Which verbs do they use when they argue? How do people write scientific papers? And even how do people draw comparisons between two objects? And we can study that by looking at languages where we can force them to actually make a comparison. So I've been at the Computer Lab, Department of Computer Science and Technology, for almost 20 years now. And before that, I was brought up in Germany. I did my first degree in computer science at the University of Stuttgart. And after getting that first degree, I studied for my PhD in Edinburgh. And there, actually, the department was called Cognitive Science. So I have a strong interest in collaboration with people who do psychology, experiments on humans, philosophy. It's kind of a broad church where I did my PhD. My PhD was on argumentation in scientific articles and how a computer can use this processing to write good summaries of scientific articles. Then after my PhD, I went for 2 years to Columbia University in New York, where I did a postdoc. And in that postdoc, I mostly concentrated on medical information retrieval. And after that, I was hired to Cambridge to the computer laboratory. And I've been there ever since.
So I love it there. Fascinating. If I think about the audience I expect to have for our chat, the audience of my small channel at the moment is mostly people who are undergraduates in computing, and they're already taking a computer course. But with these videos, the one I'm doing with you and the other colleagues and students, is to inspire people who are much younger, still at school, and have to decide what to do next. And we want to show them how cool it is to go into university, and that not all successful computer science people are white middle-class males. And so I'm interviewing a number of people who are not fitting that pattern to show how exciting the things that they did are, and figure out how they got there. So you told us a lot about, in a sense, the later part, but I would like to begin by asking you about how it all started. When you were just a teenager, when you were a schoolgirl, what sparked your interest in computing? How did you decide that you would go to Stuttgart to do a university, study computing at university?
My entry route to computer science was science fiction. I always dreamed of the future as a little girl. I wanted to be an astronaut, and I wanted definitely, I imagined the future like this jetpack crazy thing where everything would be automated and super, super cool and look very cool as well. So I read science fiction like a fiend. And at some stage when I was maybe 14, I realized probably not going to be an astronaut. I actually read up on what you have to do to become an astronaut. And at the time, it was like a military career and study aeronautics and so on. But around that time, I started really being interested in, definitely wanted to do a science, something scientific. I also had an interest in math. I also had an interest in medicine, but I chose computer science. I just thought it was a really universal subject. And here's the funny thing. I did not program a single thing before I started. I sat there, and in the first lesson, when they taught us programming languages, this is when I wrote my first line of code. I just knew that it wasn't so common at the time. I think I bought an Atari ST, like maybe just before studying or something like this.
I had one of those before.
In my circle of, I was surrounded by only boys who were interested in computer science. Many of them had programming experience, but somehow it didn't daunt me. It didn't intimidate me. And my female friends, most of them thought it was like a weird idea. And they were like, oh, this is, for some strange reason, this is not for us. But the programming itself only came when I showed up in university all excited. And in a way, university, studying computer science for me was like finding my tribe. These were my kind of people. I just felt like it was very hard. I found it quite challenging. There were things in maths I hadn't done before, but in a way, I felt that these were my kind of people interested in similar things. I talked about science fiction, everybody got it, So starting university was looking into a bigger world and finding a lot of joy, actually.
That's great to hear. So when you finally got into computing in a tribe, as you say, of other people who enjoyed the same things, what was the thing that you found most exciting?
In my course at the time, there was a new, very, very surprising minor subject. All the other minor subjects were physics and very engineering, very technical things. But then they came up with computational linguistics because Stuttgart happened to have a computational linguistics department. And I took courses in the minor subject, and I just loved it. I was surprised that we could use language to look inside people's brains. So there's some ways, if you're interested in human intelligence, how we can look inside a brain. But I always felt that language is a really rich way how people can express what's going on internally, and how we can also, even if people are not aware of it, how we can measure what's going on inside the brain, even if the person isn't aware of it. So that was maybe, in a minor subject, maybe we would only have 2 years of courses in this, but I got so crazy and passionate about it that I changed over. Formally, I was still a computer science major, but I basically did my dissertation on a subject in computational linguistics.
Which has then become your career, basically, right?
Yeah, like when I took the first 3 introductory lessons I think I would have found my feet somewhere else in computer science as well, but this interest in human intelligence, and that we even get the pleasure of even doing something with it and researching with it, kind of was a surprise to me, and then really stuck with me.
And so it's at your undergraduate level that you already started to get into computational linguistics, and then this carried through a research experience, PhD.
In a way, it's very late, because I think I had 1 or 1.5 years when I was doing the standard computer science things, compilers and architectures and standard things, without having met this minor subject. But what I think what happened during that time, so this was in the early 90s. What happened at that time is that many disciplines from outside of computer science teamed up with computer science. There was, like, for example, bioinformatics and medical informatics. And these applied subjects often attract people who don't just want to do the computer science for itself and as an intellectual pursuit, even though that's fun as well. But there's a whole range of people, what they want to do is do something in the world with computer science. And I just think computer science is a really universal tool for doing anything you want to do in the world. Like whatever you're interested in, you can play in the world of computers. If you're very theoretical, you can edge towards the theoretical part of computer science. But if you want to do something, if you want to heal people or understand how the brain works or invent better ways, I'm just reading a dissertation right now on a new way of inventing new drugs and starting a huge search space, cutting it down to possible drugs. There's so many applications in computer science that these days are taught more integrally together with the standard things. And I think when I was educated in computer science, I was lucky to just catch the front end of that development.
Yeah, you seem to have been a trailblazer, having started this thing way back then. So if we talk to young school-age young people, and what is there that we should open their eyes towards? So maybe they don't imagine that if they came to university doing computer science rather than other things, they could have so much fun. What should we let them figure out that they haven't already got in their mind? Maybe some of them think computer science is just doing Word, Excel, and PowerPoint.
Computer science is about thinking. It's about exploring ways how you think other people think or should be thinking. It's about solving puzzles, solving problems. And there's so many problems in the world. If you enjoy doing something right or finding the solution to something that isn't obvious or taking a few steps and then coming up with something, if you observe yourself in your daily lives and you're a bit like that you like these things, consider computer science, because it's one of the subjects where you can do all these things.
I would certainly subscribe to that. So you said when you were at university and you were in a minority as a girl, this didn't bother you. So can you elaborate a bit on these social aspects of just, being a girl in a male-dominated thing, and how does this affect one's outlook? And
I do think that if you're a minority in a majority world, there will be expectations that are biased against you. People will have them, even the good people who don't want to make you stick out. You will just notice that you stick out. And if you're a girl in computer science, I was exotic and I made lots of friends and male friends. I also made some female friends there. I didn't perceive it from a social aspect as weird. There may have been some of our educators who were slightly biased against it. When I was at university, I was often praised for doing something as a girl, which I found a little bit belittling. But I think, like they would today, they're trying to be fair. The question with bias against women or all kinds of minorities is often the problem of when people who actually mean well don't even realize it. And there's just there's expectations in you that are lower than they are in the others. And it's, in my life, even later in my working life, I've never made any blaring bad experiences with it. I've come across many men who actually tried to mentor me and who meant well with me and who were nourishing me, particularly. I've also come across really little situations that were very thoughtless, where I could feel that a whole stream of negative emotions towards me is coming. I'll give you one example. I was in a committee meeting in an unnamed university, and the chairman, who was kind of the older folks, and I kind of could feel that he was quite conservative. He suddenly, in the middle of discussing something, quite normal, business-like, complained about a woman in administration. And he said, I just wished that she would go back to basket weaving. And the atmosphere in that whole committee was that everybody laughed at this joke. And you know what? I laughed too. I could feel it, that it wasn't right. But that was the atmosphere. And I think what I'm just describing is the kind of thing that many women will recognize. It's stuff like not letting you speak in meetings, taking the idea out of your mouth and presenting it as their own. There's a lot of misdemeanor like this. And are you going to ask me what we can do about it?
I'm just going to ask, what should, in this case, a young woman, a girl of 15 who's considering, actually, I think I might enjoy computing, but it's such a male-dominated field that I might encounter this kind of thing, and this puts me off. And what would you have to say to her?
I wouldn't lie to her, and I wouldn't say, oh, no, it doesn't exist, because I think it wouldn't be fair. I would not want to convince someone to do computer science thinking that this problem doesn't exist. It does exist, but I think there's a lot of goodwill in the world. And that thing that happened to me was 15 years ago. And nowadays, the old dinosaur chairman has retired. Young men have come into our department, and I see social change. There's many men now who would have said something. Maybe I would have said something now, after observing this for a while. I think, and also we, the women, the girls, we can do something as well. Like, I wasn't very brave, but I knew that it wasn't right. And I think I spoke to other women about it, and it was known that that guy was a particular dinosaur. And that was the age of the death of dinosaurs. And he was starting to be, starting to be marginalized. And I think generational change often happens by the old folks and the old brains dying off. But I see now, for example, young men who have childcare responsibilities, and they speak up much louder than the women who look after kids. And stuff like that creates an atmosphere where it's suddenly okay to have a child and to say, no, I don't want to do that. I have to pick up my kid from kindergarten. And the atmosphere in the department, I would say, is definitely not behind the rest of society. I feel it because so many young, open-minded men have come. In my field, by the way, women are 50%, so it's less of a problem in computational linguistics itself. But I feel the wave of the times are swinging in such a way that it is more manageable, it's more noticeable, and it's more okay to say something about it. Mm-hmm. So I would tell the girls, speak to each other, be sensitive. If something doesn't feel right, if somebody says something to you and it doesn't feel right, at least notice it. Maybe say something if you're courageous. If not, talk to others about it and think of a way how certain aspects, microaggressions, certain statements, certain things that you don't like, anything you don't like as a minority person probably has some, you have the right not to like it, and you have the right for others to change it. And I feel that also I mainly speak for our department, but in our department, there's also a very strong HR, human resources, infrastructure, people who care about these things that you could talk to. I think if you're in an enlightened company, even if you're in a big tech giant, I know that, nowadays, companies care about diversity. Universities care about diversity, not just because they want to be nice to women and to people of other ethnic backgrounds. They care about it because it actually makes for a better company and it makes for better ideas if you have people in committees who look at stuff from different viewpoints. And in that way, I have lots of hope. And I think the fact that it's mainly a male-dominated area, it's shifting. There's application areas where there's more women than men. And also, I think it's shifting over time. And it makes the field more interesting.
Do you have any insight as to why historically there have been many more boys applying to university to do computer science than girls? I mean, I have a suspicion that it was drilled into them from when they were little that it was not a thing. You know, technical stuff was not for girls for some reason, which I can't really fathom. But
no, I don't. Yeah, I think there might be. You know, it's the nurture versus nature argument, and there might be something in the nature of girls that this type of technical involvement with the world is less interesting. But I suspect that culture and upbringing has a huge say in this. So Tim Griffin, one of our colleagues in the department, tells the story of when he traveled to Malaysia 10 years ago to examine a PhD in Malaysia. And there, he was surprised to see that 50%, more than 50% of the computer scientist graduates are women. And when he asked about, in the UK, computer science is seen as a man's job. Why isn't it here? He had one of the young women say to him, "It's not dirty. It's not heavy work. I can even look after my kids while I do it. It's a perfect women's job." And that is a perspective from a developing country. And I just love this story because it is a perfect women's job. And their fathers of the middle classes or even of working classes in Malaysia, what they wanted is for their daughters to be financially independent. And there, it was a perfect women's job. And I think it can be here too.
It's a good story. So in your path in computing, has there been a person that you found especially inspirational? It could be a person that you've actually met, or it could be a person who wrote a book and you never actually met the person, maybe dead before you were born or something. Is there someone who was a figure that was an inspiration for you, or maybe several? I don't know.
Because I didn't read computing books, I would say that there wasn't someone in my early career that was a role model or that I looked up to. I would maybe say some of the science fiction writers, but then when I was in my postgrad, I met a female professor who is exactly how I want to be as a professor. And she's called Kathleen McEwen. She's at Columbia University. And she has become a role model because she was a very good computer scientist, very good thinker, but she also showed us with how she lives that you can have a good work-life balance. She was very fair to students. She was kind, but she wasn't a pushover. If you did something wrong, you would hear it in certain terms, and then she would move back to being a very neutral and perfect professor. And and she had 3 kids and organized everything in such a way that she was super dedicated, very successful, and still had a nice life. And I just thought like, wow, I want to be Kathy McEwen. I worked with her for 2 years. We became friends, but it was really cheering me up to see that. And if I think back to my life, there are many successful computer scientists who lead a well-rounded life.
It's very nice to hear. What would you say is the thing you've done in computing that you're proudest of?
For my PhD, I wrote a big program, and it was written in Perl, which is a precursor language to Python, which I use now. And that that's the biggest thing I did in my computer science career. It trawls through millions of scientific articles, and it looks at sentence by sentence, and it finds the features that in the previous machine learning training that I was running on texts have been learned to indicate certain things. So what that program is doing is trying to find sentences where you criticize, where the author is criticizing some other author, and other sentences where the author is describing somebody else's work and praising it. And that can be done by using different verbs. It can be done by saying in this paper, and you're pointing out that you're doing something that nobody else has done before. It can be done by using negative adjectives like worrisome or labor intensive or any other such negative adjectives. And once the program has gone through the entire text, it compares the sentences to each other and gives you the areas that most likely point to other people being negatively evaluated. And that can be used in search engines. If you're looking for a scientific, it's not so much about negative, it's often finding the aspect in which you compare yourself to someone else's work, where you're making a departure from that. And that can be used for more intelligent search engines that help you find scientific articles that have something to do with your work in a particular way. So I worked on that throughout my entire PhD, and I continue working on it for some years. And at the moment, it's a bit on the back burner, but understanding how people argue in texts is just a recurring interest of mine.
So this prompts me to, let me just get the book I have here on the shelf. When I was at the beginning of my university undergraduate course, I came across this book, Gödel, Escher, Bach, which I'm sure many people will be familiar with. And she's gonna get her own copy, I'm sure. There we go. So I didn't go into artificial intelligence after this, but I was really fascinated by the idea of artificial intelligence from this book, and the idea that maybe if we write computer programs that simulate intelligence, we can understand more about intelligence. And what I have seen happen since, I mean, I was not involved directly in research in AI, but I just kept an eye on what people were doing, was that we built systems that look like they take intelligent decisions, but nobody can understand why they did it. It's just some kind of statistics which are a black box. What would you say about that?
Yeah, I would say that the field is often, the field of AI, so Hofstadter's time was the first wave of AI, and people did everything symbolically. And you know how the pendulum swings. Hofstadter was at the end of that. And then now we have the age of statistics, and people have concentrated on building machines that mimic human behavior. And they often do this pretty well, but there's, of course, certain problems with not understanding what they are doing. And I don't want to do injustice to the field. There's a huge subfield right now in this purely statistical artificial intelligence that is called explainable AI, and where people are trying to use other machine learning techniques to interpret internal states of neural networks to explain what the neural network might be thinking. My general idea is that all of this is a bit too extreme, and my research is going in directions where we have internal representations that a human can inspect and understand, and we do little bits of machine learning from these internal representations. There might be criticism that I might not have got those internal representations right, but I feel it is safer to have a machine decide something if I can inspect which internal steps it took. I'm speaking a bit against the grow of the field, but I'm very worried about unexplainable AI and people putting too much, for example, when the legal system is involved, you know, when entire society can suffer a lot from it. I believe we have to think very carefully about the evidence we have of the system coming to its decisions. And then there's also some research I'm I'm involved with that looks at bias in systems. So if you have, what should you do in a society where, for example, if you have a legal AI that is determining who gets bail and who doesn't get bail, and that has been trained on the current situation, and that will, of course, if you're a Black person, you will be 3 times more likely by this machine not to get your bail. Now, that's not fair. There's internal baked in biases as well against women when you can learn what words mean by simply looking at the co-occurrences of the words. And from that system, you learn that women and engineer is very far removed from each other, and homemaker and women is very close to each other. So there are efforts of how we can fairly debias such systems to work towards the kind of society we want and not perpetuate with our automatic decisions the society that we already have.
Yeah, if the artificial intelligence is not based on intelligence, but is based on copying statistically the examples that you've shown before, it can perpetuate the bad things that have happened if that's all they see, right?
Yes. We're talking about supervised machine learning here, and there are also unsupervised mechanisms, and they are inherently a bit less, they're much less powerful in what they can do, but they have this problem a bit less. So what I do in language and AI is much more interested in explicitly showing how reasoning works in our minds. So, for example, if I give you a let alone sentence, something like, you can't eat one of those cakes, let alone 3 cakes. What we have there is we've got 2 hypothetical situations that we compare, and one of them is more likely. And then people use that to reason. So I'm currently doing a project with a student where we look at 100,000 of those sentences and try to work out what the underlying logic is. In the case that I just told you, it was like, the more you have to eat, the less likely it is that you can eat this. But there's many other mechanisms inside. And in this particular case, there's a little intelligence in the machine, and we know exactly why.
I think we could go on with this for a very long time. It's really fascinating. We could let the hours fly by without noticing. But let me ask you just one final question. And that's, there's a stereotypical image of the computer nerd or geek. What do you have to say about it? Is it an accurate representation of computer people? Does it match your experience of the other people in computing that you've met? Do you consider yourself as one of those? Is it necessary to look like this in order to be successful?
I consider myself a geek. I'm a full-on geek, and I like geekiness, and I see it in many of my students that I come across. I see in geekiness the drive to do something right, to have infinite attention, have long attention spans, want to know what's right, and then sometimes maybe be a bit righteous and insist on your opinion, and also enjoy things like what I just did. What I'm going to do after this interview is go through a long list of metaphors found in text and decide for each of the list whether it is a metaphor by some strict criteria. I mean, you want geekiness, and I think geekiness is distributed in girls and boys, and across in any nationality and ethnicity. And geekiness is good. You want a geek to decide how your nuclear power station is run, and you want a geek to decide that the operating theater in your hospital always works. So I see geekiness. I think it doesn't have to be a contradiction with also being socially aware and having other interests in your life, but that little bit of geekiness I almost see in every computer scientist. If you don't have a little bit of a geek inside you, maybe that's not the subject for you. It's my opinion.
Thank you very much. Do you have any last words that you want to impart your wisdom through?
No, I just want to say that, Frank, it is a very great idea that you're asking women computer scientists for their experience. And I hope this series goes well.
Thank you. Thank you very much for your time and for sharing your experience.
Bye.
Bye. See you soon.